welcome to everyone. In today's video lecture series, we are here to present on the topic case study on self-compacting concrete. So before moving to the topic, let us recall what is self-compacting concrete. Self-compacting concrete is a kind of concrete which flows by itself and compacts by itself without the use of vibrators and other compaction equipments, so that a concrete made is more workable and easily flowable, so that we can achieve the workability at a faster rate, and also improves the other characteristics of concrete such as durability, workability, compressive strength, etc. So let us dive deep into the topic related to self-compacting concrete. So in this case study, we are here to explain about the usage of self-compacting concrete in various applications. So over to our team for further explanation regarding self-compacting concrete. So Niranjana will explain about the introduction regarding this.
So hello guys, so first we are going to be discussing about why the self-compacting concrete was found in the first place. So in 1983, there occurred a great problem while studying the durability of concrete structures in Japan. The problem is that the concrete wasn't durable and it wasn't requiring the adequate compaction by necessary skilled laborers. So as a solution for the above problem, self-compacting concrete was created by Professor Dr. Hajime Okamura. So the key problems identified in Japan were poor compaction in congested reinforcement areas, high noise and labor demand due to vibration, defects like honeycombing and voids. So the definition of self-compacting concrete. Self-compacting concrete is a concrete that can be compacted into every corner of a formwork purely by means of its own weight without using any external vibrators.
Brainstorming solutions, use of superposition and viscosity modifying agents, optimizing fine to coarse aggregate ratio, replacing part of cement with fly ash or silica fume for better flow, adjusting water power ratio. And materials required is cement, fine aggregate, coarse aggregate, water, and chemical admixtures such as superplasticizer, viscosity modifying agents, and air entrainment agents. Mineral admixtures such as fly ash, GGBFS, silica fume.
So coming to the properties of self-compacting concrete, in fresh state, self-compacting concrete have the following properties. First one will be the filling ability. It flows easily at certain speed into formwork. Then the passing ability passes through reinforcement without blocking. Segregation resistance, the distribution of aggregate particles remains homogeneous both vertically and in horizontal direction. The common tests conducted in self-compacting concretes are slump flow test, T50 slump flow test, V-tunnel test and V-funnel test, L-box test and U-box test. Coming to the slump flow test, the procedure will be a normal slump cone and a flat square plate is taken. Some concrete concentric circles are drawn on square plate. A foam circle of 500 mm dia is drawn. The slump cone is then filled with about 6 liters of concrete and is raised vertically, allow the concrete to flow free in horizontal direction. It measures the final dia of the concrete in two perpendicular directions and note the average of two diameters. Now the T50 slump flow test. This procedure is the same for a slump flow test. When the slump cone is lifted, start the stopwatch and find the time taken for concrete to reach 500 mm mark. This time is called the T50 time. A lower time indicates greater flowability. It is suggested that T50 time may be 2 to 5 seconds.
Next is V-funnel test. The V-funnel test is used to find filling the ability of aggregates of maximum size of 20 mm, and V-funnel at the T5 minimum is used to find the segregation resistance. The equipment consists of a V-shaped funnel. Procedure for the V-test is the door present below the V-funnel is closed and about 12 liters of concrete is poured inside, and open the door within 10 seconds and record the time taken for concrete to flow down. The whole test is performed within 5 minutes. Procedure for V-funnel test. Do not clean or moisten the inside surface of funnel. Close the trap door and refill the V-funnel. Now open the trap door after 5 minutes and allow the concrete to flow down. calculate the time taken for the complete fall of concrete. It is called the flow time at ET minimum. Acceptability. For refunnel test, the flow time should be between 8 to 12 minutes. For refunnel at T minimum plus 3 seconds allow 11 to 15 minutes.
So L box test, this is used to know the passing ability of the concrete. So about 40 liters of concrete is taken and fill the vertical section of L box. So lift the gate and allow the concrete to flow out into the horizontal section. Start the stopwatch and note down the time taken to reach 200 and 400 mm marks. So when the concrete stops flowing, the height H1 and H2 are measured. Calculating the blocking ratio by H2 divided by H1. The test is to be performed within 5 minutes. And acceptability, if the concrete flows like water, then H2 divided by H1 is equal to 1. The minimum acceptable value is 0.8. Then coming to U-box test, this is the test done to measure the passing ability of concrete. So the procedure, about 20 liters of concrete taken and it's poured on one of the side of U-box. Leave it stand for 1 minute, lift the sliding gate and allow the concrete to flow to the other side. Once the concrete has come to rest, measure the height of the concrete at both sides. H1 is the height of the concrete in first compartment and H2 is the height of the concrete in second compartment. So calculate the filling height by H1 minus H2. The whole test is to be completed in 5 minutes. Acceptability, if the concrete flows like water, then H1 minus H2 is equal to 0. It represents the better flow and passing ability of SEC. The acceptable value is the filling height should not exceed 300 mm.
Advantages and disadvantages will be explained by Gurnesh.
Advantages and disadvantages of self-compacting concrete. Reduction is saving manpower and problem caused by the vibrators and reduced, easy to place and fast construction and better surface finish, improving durability due to better compaction and homogeneity of concrete. And disadvantages of self-compacting concrete: a high cost volume result in the great shrinkage and creep. The mixed design and procedure adopted is too complicated for the practical implementation. It required more trial batches and costly on the conventional concrete based on the material.
Okay. I hope this video regarding the self-compacting concrete would be useful for everyone who are in the 5th semester of concrete technology. The course offers 23 CET 303. It is one of the most important topics in Unit 12 of concrete technology. So let us summarize what we have learned in today's class. First, we have learned the importance, introduction and development of self-compacting concrete, and also the materials required for production of self-compacting concrete, and the properties and the various testing methods involved in ensuring the workability of self-compacting concrete, and finally the advantages and disadvantages. So thank you for listening to a case study video on self-compacting concrete. Have a good day.
Interesting.